We already know how to solve systems of equations by graphing and by substitution, and today we're going to start learning solving by elimination. So, remember what we can do with equations. We're allowed to add the same thing to both sides, multiply both sides by the same non-zero value. We can also subtract the same things from both sides. We're going to use these facts as we solve by elimination. In elimination, our goal is to eliminate one of the variables. So we're going to start with two equations and two variables. We want to eliminate one, so we have one equation, one variable. Let's look at an example. So just like we can add the same thing to both sides, we can add equivalent things to both sides of an equation. So to this side of the equation, the second equation where there's a 3, I'm going to add a 32. Now, to this side of the equation over here, I'm going to add not a 32, but something that's equal to 32. What do I know that's equal to 32? 4x plus 6y, I know happens to be equal to 32. Now, why am I going to go through that trouble? Well, this actually achieves my goal. Watch. When we add these together, well, 32 plus 3, that's pretty easy. That's going to give me 35 on this side. What's going to happen over here on this side, though? When I combine these like terms, the positive 6y and negative 6y makes 0 together. 4x plus 3x gives me 7x. Notice what I have now. I have one equation, only one variable. 7x equals 35. That's pretty easy to go ahead and solve just by dividing by 7 on each side. So now I have x equals 5. Great. Once I know x, I've got equations that I can use to figure out y, just like we did in substitution. You can choose either the first equation or the second equation. For this one, I'll go ahead and choose the second. Now, in place of x, I'm going to put 5. Now I've got x equals 5 and y equals 2, so I know my solution is 5, 2. Of course, I can check by plugging back into the original equation. 5, 2 works for both equations, so I know my solution is correct. Now notice, this happened to be pretty convenient that I had a 6y and a negative 6y, which just happened to cancel each other out when they got added. We'll look at some slightly harder example right now, and on Monday, we'll look at some even more complicated examples. Okay. Now I can't just go ahead and add these two together because then I'll end up with 16x, 10y, and 17 on this side. I haven't canceled out any variables if I do that. What's another option? Well, remember I'm allowed to subtract the same thing from both sides. What's the same as doing that is going ahead and multiplying everything by negative 1. So I'm going to take the second equation and I'm going to multiply it by negative 1. On both sides. I know that's something I'm allowed to do. That way when I add these two equations, I will have canceling. Let's see. The first equation stays the same. The second equation, I've multiplied everything by negative 1. Now when I go to add, 8x and negative 8x makes 0. So I just have negative 4y equals 4. Divide by negative 4, and I get y equals negative 1. This time I'm going to have to substitute to find x. I can choose either the first or the second equation. I'll choose the first. So I've got x equals 14 over 8. Simplify that to 7/4, or you can write it as 1 3/4. Let's write out our solution. And again, you can check by plugging into your original equations. This works with both equations, so I know my solution is correct. Now you might ask, well, what if I can't just simply add or subtract? What happens then? And that's what we're going to talk about on Monday. Great job.